Okay, section 15, the normal distribution. This is on page 187. Okay, yeah, so the first part of section 15, we talk about the normal distribution. Okay, the second part of this section, we talk about what? Z-score. The third part of this section, we talk about percentile. So there are three parts, okay, from this section. Okay, we're going to talk about these parts one by one. Okay, the first part is about the normal distribution. Okay, so I'm going to assign the pages we're going to cover for the entire section 15. Okay, and then we come back to look at each part one by one. Okay, so page 187, I want you to read through, okay, the entire page, okay, and work on the question, read through the definitions for what is a histogram. Okay, so entire page 187. Page 188, entire page, talk about the data distribution. Okay, what is a normal distribution curve? Okay, so entire page. All right, page 190, entire page. Yeah, what does it mean? Okay, standard deviation. Okay, entire page 190. All right, on page 191. Okay, above the Excel part, question 5, 6, and 7, do all of these. Okay, yeah. Excel part, self-study. Okay, yeah. This part tells us how to use Excel to compute a mean. Okay, and also compute a standard deviation. Self-study this part. Okay. All right, page 192, entire page. Page 193, discover part. Okay, the entire discover part. Page 194, entire page. Okay, this is about Z-score. Okay, entire page 194. Page 195, entire page. Page 196, entire page. Page 197, entire page. Page 198, discover part. What is a percentile? Okay, discover part. Page 199, entire page. Even if it's explore, we also have to know it. Okay, yeah, 199, entire page. So that's it for section 15. Okay, so many pages, right? Okay, so let's go back to page. Let's see which one. Okay, let's go back to page 188. Okay, page 188. All right, we talk about normal distribution at the first. Okay, normal distribution. All right, so on this page it says for data distributions, okay, data can be distributed in many ways. Okay, sometimes the data is skew left. Do you still remember the definition for skew left? If the data has a long tail on the left, okay. Sometimes the data is distributed for skew right if we have a longer tail on the right. Sometimes it's unclear. Okay, we don't know. Okay, whether it's this or that. It's unclear. Okay, but there are many cases that the data is spread out symmetrically, okay, with most values clustered in the middle, say most value clustered in the middle, and fewer values on the lower end and also on the high end. Okay, so if this is the case, okay, we then use what? A bell-shaped symmetric curve to describe this data, okay, and then we call this data value satisfy what? Okay, yeah, this curve, okay, we call it is normal distribution curve. Okay, all right, now I'm going to ask volunteer to read this paragraph, and also read this gray box for us. Whose turn? Irma?
In fact, when very large amounts of data are collected, the data will often start to form a bell-shaped curve. In this graph, a perfect bell-shaped curve has been overlaid on the data. This perfect curve is called the normal distribution curve. In this section, we will be studying the characteristics of the normal distribution. Because the actual data set is assumed to be close to the perfect normal distribution curve, we can use these characteristics to analyze the data. Characteristics of normal distribution. Mean equals median equals mode. Symmetry about the center. 50% of values less than the mean and 50% greater than the mean. Never theoretically touches the horizontal axis area under the curve represents probability.
Okay, good. Okay, very good. Okay, so far we know a normal distribution curve is a bell-shaped symmetric curve. Okay, so also we know some characteristics of normal distribution. You may highlight this. Okay, we know for all of these data's values spread out on this horizontal line. Okay, mean, median, and mode are all equals each other for a normal distribution. They're also symmetry about the center. Okay, yeah, symmetry, data value spread out, symmetric, about the center. All right, and then we know if this is the mean, median, mode. Okay, for normal distribution, mean equals median equals mode. Okay, 50% of data values will be less than the mean. 50% of data value will be what? Greater than the mean. Okay, all right. So under the area under the curve represent probabilities. That means 50% of the data values is less than the mean, and then 50% of data values are greater than the mean. We represent probabilities. Okay, 50% on each side. Okay, on each side. All right. So we briefly know this. Okay, and then let's turn to page 190. Okay, so for normal distribution, guys, let's look at 1, 2, 3, these three pictures. Okay, these three pictures, we're not going to read through these questions in detail. Okay, but what we can see is for all of the three pictures, okay, those data values are all satisfy a normal distribution. Okay, follow a normal distribution. And then they represent, these data values tells us for different cities, Austin, Indy, and San Diego, about their September temperatures. You see, even if all of the three data values, three pictures, we can use normal distributed curve to describe them. But you can tell them that they don't spread out the same, right? See, this for San Diego, temperatures are more clustered in the middle. Do you see that? And then Austin is kind of in the middle of between San Diego and Indy. For Indy, the September temperature is more spread out. That means there are more hot days. There are some colder days. Okay, more spread out. Okay, so San Diego is mostly kind of in between, right? So more clustered in the middle. Indy is more spread out for the temperatures. Okay, so all of these three, they are normal distribution curves. Okay, however, they do not spread out the same. So how to measure for normal distribution? The data value is spread out. We use this word and phrases to describe it. It's called what? Standard deviation. Okay, so I'm going to ask volunteer to read this paragraph about standard deviation. Damon?
Every normal distribution is described by mean average, and the measure of its spread called the standard deviation, called the standard deviation. Standard deviation is a calculated value that indicates how much data the data set deviates from its mean or average value. A curve with a larger standard deviation will have more spread out data, while a curve with smaller standard deviation will have data closer on the mean.
Okay, good. Okay, so here, standard deviation calculated value indicate how much the data set deviates, from its mean. Okay, so here it says, curve with large standard deviation will have more spread out data. Okay, curve with a smaller standard deviation will have what? Data clustered around the mean or in the middle. Okay, clustered in the middle. Okay, so the more spread out the data, the larger standard deviation it is. Do you see that? Okay, Alright, now let's turn to page 191, okay? And then let's answer this question 5, 6, and 7, okay? Yeah, look at the question, please. Look at it. Below is a graph of two normal distribution curves with the same mean. Yeah, what is the mean value? You can tell it's about 70. And what does this normal distribution curve represent? Course grades. Okay, course grades. The solid line give us what? Spring semester, the grades, okay? Dashed line give us the fall semester, our course grades, okay? Yeah, we can tell very clearly that they do not spread out the same. They have the same mean. Mean means average score, okay? For both fall semester and spring semester, students' grade, our mean value is 70%, okay? C, okay, it's a C. Alright, question 5. Which curve appears to have a lower standard deviation? Just talk about standard deviation, right? Lower standard deviation give us what kind of data values? Spread out or clustered? The larger the standard deviation, the more spread out it is, right? So lower standard deviation means what? Data values are more clustered in the middle. So which curve appears that? The solid line or the dashed line? Spring semester. I would say spring, okay? Or the dashed line. You say dashed line, okay? I would say spring. What does that mean? Means for the spring semester, most of the students, their grades are closer to a C. Okay, so most of them, they're close to a C. But there are fewer what? A's and B's, fewer what? Students fails, okay, less than 60. Okay, most of them, more of them, they're more close to 70%. Question 6. In which semester did the student receive more F's? See? Horizontal line give us the scores, 50 points or 50 percentile, not percentile, 50%, 55%, 70%, and so on. And then this vertical line give us what? Counts. Okay, yeah, so this vertical line give us what? The counts. Say 120 students get a C, 60 students get a whatever, okay, 40% get a whatever, okay. Horizontal line gave us the scores, vertical line gave us the counts of the students. So which semester the student receive more F's? F's means what? Below 60, right? So which semester gets more counts? Fall. Because fall, this curve is above this dashed line, right? Above the solid line, right? So fall get more F's. Fall also get what? More A's and B's, right? But fall get less what? C's. You see that? Okay. Question 7. When were more C's earned? Spring, right? Yes, spring. You guys feels good? This question, I would say, it's a question talks about what? Standard deviation. Okay? Yeah, the larger standard deviation, the more spread out the data. The less standard deviation, the more clustered data sets we have. Right? Alright, so these are, what is standard deviation? That's a bell-shaped symmetric curve. What is standard, the normal distribution is bell-shaped symmetric curve. Standard deviation gives us what? How spread out the data value. Okay? Alright, so let's turn to page 192. Empirical rule 68%, 95%, 99.7%. Yeah, I would say this part is very important, okay? So, what are these rules, okay? I'm going to ask a volunteer to read this paragraph and plus all of the 3 gray boxes for us. Whose turn? Kathleen?
It turns out all normal distributions have the characteristics described on this page. The diagrams on this page are normal curves with a mean of mu. Is it?
Yeah. Mu,
And
yes.
a standard deviation of sigma. Notice the mean is at the center. Adding 1 standard deviation would be mu plus sigma. Subtracting 1 standard deviation from the mean is mu minus sigma. The area under the curve represents likelihoods and probabilities. Approximately 68% of the values are within 1 standard deviation of the mean. Approximately 95% of the values are within 2 standard deviations of the mean. And approximately 99.7% of the values are within 3 standard deviations of the mean.
Okay, good. Okay, very good. Alright, so for normal distribution, okay, we see that, okay, if it has mean, okay, mean value, we use the Greek letter mu, okay, mean is always in the middle for a normal distribution, okay, so mean is in the middle, okay, and we know what? Sigma is what? 1 standard deviation, okay, yes, a standard deviation, 1 standard deviation is mu. Alright, so we could mark the data values, okay, with mu and sigma on the horizontal line, okay. Say mean is always in the middle, okay, mu, okay. So the data value which is 1 standard deviation bigger or large than the mean should be mu plus sigma, okay. So it is to the right of the mu, okay. If a data value is 2 standard deviation above the mean or bigger than the mean, we say it's mu plus 2 times sigma. Sigma represents 1 standard deviation. 2 times sigma represents 2 standard deviation. So mu plus 2 sigma, this data value is 2 standard deviation above or bigger than the mean. And then mu plus 3 sigma has a similar idea. Mu minus sigma, 1 standard deviation below. Mu minus 2 sigma, 2 standard deviations below. And the mu minus 3 sigma, 3 standard deviation below. Okay, so we can always use mean and the standard deviation to mark. Okay, yeah, to mark this horizontal line like this. Okay, always put mu in the middle. All right, this rule is telling us what? Approximately 68% of the values are within 1 standard deviation of the mean. What does that mean? Within 1 standard deviation, 68% of data values is either, less than, 1 standard deviation less than the mean or above and in between. Okay, so that means what? It's more clustered in the middle. See the example, guys. Our Math 123 test scores. Okay, what is the mean value? See the example, 70%. See the example, 70 points. Okay, so if I say every 1 standard deviation is 10 points, so what is 1 standard deviation below the mean? 60 points. What is 1 standard deviation above the mean? 80 points. So this rule is telling us what? 68% of us, your grade, will between what? 60 points and 80 points. So this is just an example. That means what? A lot of us were just what? Around the mean. Another example is what? IQ score. Do you know IQ score? I think the average IQ score is 100 points. Have you heard about IQ score? We can't get tests, So most of us, 68% of us, our IQ score is what? Within 1 standard deviation of the 100 points. Okay, your IQ score may be below 100 points. Your IQ score may be above 100 points. 68% of us, our IQ score is just close to that 100, but either below or above. Right? So this is a percentage. You guys get an idea about this rule, okay? 95% of the values are within 2 standard deviation. What does this mean? Oh, within 2 standard deviation, 95% of our scores are within 2 standard deviation. Okay, that's 95% is a large percentage. And within 3 standard deviation, 99.7%. Not 100%, but this is almost everything. But not everything, but almost, right? So within 3 standard deviation, 99.7% of the data value are within 3 what? Standard deviation. So these are these rules telling us. You guys get an idea about these rules? Alright, now our aim is to understand this table and then be able to do calculations. Okay. So I need you guys to really understand this table. Okay. So this is the mean, mu. These are the data values above or below 1 or 2 or 3 standard deviations. Okay. Because we talked about what? 68% of data values is within 1 standard deviation, right? So I say there are 34% of data value are between 1 standard deviation below the mean and the mean. You guys see that? Okay. We cut 68% into 2, into half. We get a 34. Okay. So this part is 34. Means, oh, the percentage of data values are 4 on this interval is 34%. 34%. Alright, now do you understand why between 2 standard deviation below and 1 standard deviation below, why we have this percentage for the data values? Do you understand how we get 13.5? Do you know how? I don't have a pencil, but I want to just write it here. 68% in both directions, right? 1 standard deviation in both directions of mean. What is within 2 standard deviation? What is it? You remember? 95%. Right? So 95%. This is 95%. This is 68%. I'm asking you, what's the difference between 95 and 68? Can you give me a number for the difference of 95 and 68? 27%. This 27% is a sum of these 2 intervals. You agree with that? Because see, 95 minus 68, the rest of the 2 should be these 2, right? In total, 27%. So cut 27% into half. Each interval should count for what? 13.5%. Do you see this? You guys? Okay, so that's how we get 13.5, 13.5. And then why on this interval we have a 2.75%, 2.35, and 2.35. Why? Because 95% within 3 standard deviation is going to be what? 99.7, right? So 99.7 minus 95%. Do the math. What is that? What is the subtraction? Result of this subtraction. What is it? 4.7%, right? You guys see that? Okay. 99.7, 95. So on this interval and on this interval, okay, this interval and this interval, in total, the percentage is what? 4.7. See here, on this interval and this interval, this one and this one, in total is going, oh, sorry, this one and this one, in total is going to be what? 4.7%. Why? Because that's the difference between 3 standard deviation and what? 2 standard deviation, right? So these two part together 4.7%. So cut 4.7% in half. We'll get what? 2.35, 2.35, right? Okay, and why this left tail account for 0.15% of data and this right tail account for 0.15%? Because what? Because on the entire horizontal line we have 100% of the data. Within 3 standard deviation we have 99.7. So the sum of those two tails should be what? 100% minus 99.7% give us what? 0.3%. 0.3% cut into half. That's how we get the 0.15% on each tail. You guys? And then these are the specific, each interval is a percentage. If we add up everybody, the total sum should be what? 100%, okay? Because on the entire horizontal line, in total, there are 100% of the data, okay? And then we know that less than the mean, what is the total for this percentage? 50%. What is the total for this percentage? 50%, okay? Because for normal distribution, remember we talked about this just now, right? 50% of value are less than the mean, 50% of value are greater than the mean, right? Entire horizontal line, 100%. Within 1/3 deviation, 68%, 95%, 99.7%, 100%, okay? And then this is a detailed analyze about on each specific interval, how much percent of data values it will count for, okay, it will count. Okay, well, let's answer this question 1, 2, 3, and 4 together, okay? All right, question 1. What is area under the curve to the left of mu minus sigma, okay? Area under the curve is the same thing as what? Percentage on the intervals. It's the same thing, okay? We talk about areas under the curve. It's the same thing as percentage lie on the interval, okay? So, area under the curve to the left of mu minus sigma. How much percent? What do we do? Add up what? Add up 13.5 by 2.35 by what? 0.15. What do you get? Do you get a 16? To the left of mu minus sigma, what is percentage? Add up everybody, do you get a 16? Yes, 16%. Or, do you have another way to compute the percentage on this interval? Remember, less than the mean, it is what? 50%. Between mu minus sigma and mu, it is 34. So we use what? 50 minus what? 34. We also get what? 16. You guys do see that? The way to compute the percentage is not unique, okay? It is not unique. Alright, question 2. Area under the curve to the right of mu plus 2 sigma. To the right of mu plus 2 sigma, what is the percentage? Anyone know?
2.5.
2.5. How did you get 2.5?
2.35
Plus 0.15, yeah, right? Everybody agree with that? Yes, okay? Yes, you're right, okay? Well, there are some other ways to do it as well, okay? But the most straightforward way is just add them up, okay? 2.5%. Question 3. If all of the percentage in the diagram are added together, they equals what? Equals what? How much percent? 100%. Okay, 100%. Last question on this page. The area under the curve to the left of mu plus 2 sigma is what? Either you add up everybody on each of the intervals, or remember, to the right of mu plus 2 sigma, what is the percentage? 2.5, right? And on the entire horizontal line, it is what? 100%. So how to compute the percentage to the left of mu plus 2 sigma? What do we do? I'm going to use 100 minus 2.5. That will give us what? 97.5%. You guys agree with that? Entire horizontal line 100%. To the right of mu plus 2 sigma, 2.5%. So the leftover will be what? 97.5%. Everyone? You guys? Alright, so this is page 192.